Today we will discuss about the basics of tissue processing. Tissue processing is the technique by which fixed tissues are made suitable for embedding within a supportive medium such as paraffin and consists of 4 sequential steps: fixation, dehydration, clearing and impregnation. But before any of this is done, the sample is received. The sample is placed in a wide mouth container. An adequate fixative is added. The sample which has come for testing should be properly labeled with the person's name and, most importantly, their MRD number. The MRD number of the sample is cross-checked with the one on the form by the lab assistant. Inking is the process that is done for the identification of the resected tumor margin. Gross processing or grossing is the process by which pathology specimens undergo examination with the bare eye to obtain diagnostic information, as well as cutting and tissue sampling in order to prepare material for subsequent microscopic examinations. The cut samples are then placed in cassettes and taken for further processing. There are 6 different types of cassettes based on color: red for renal biopsy, pink for cardiac biopsy, blue for small biopsy, white for large biopsy, yellow for bone marrow, and green for all true cut biopsies. The actual tissue processing is an overnight process which has 3 main steps: dehydration, in which the most commonly used substances are alcohol and acetone as they are cheaper. Ethyl alcohol is preferably used. Next is clearing, which is basically de-alcoholization. The commonly used substances are xylene and chloroform. Then comes impregnation, in which the tissue is transferred to a container containing molten paraffin wax. The next step is embedding. In embedding, we use L molds, which are customizable molds. The wax is poured and the tissue is embedded along with the number tag. The wax is allowed to harden and form a block. The tissue should be placed with their cutting surfaces down on the mold. Once done, these are placed on embedding trays. The next step is section cutting using a microtome. The section should be ideally 2 to 4 microns. In Amrita, the section is 3 microns in size. The types of microtomes are rotatory, sliding, and rocking. As you can see, the section slide has been put into a flotation bath. The next step is staining. Staining is a process by which we are identifying and differentiating the structures of tissues. The dyes may be natural or synthetic. There are two types of staining techniques, manual and automatic. Here Revati ma'am is showing us the slides which are stained with PAS or periodic acid shift stain and silver stain. All slides that come to the department are either manually or automatically stained with H&D. There are 23 special stains. The next step is mounting. As we can see here, the lab technician is placing a drop of DPX mountant on the cover slip and the slide is placed over it. The next step is labeling. As we can see here, the glass slide is engraved with the identification code of the patient. This is a decalcifier that is responsible for decalcification. For the microscopic examination of calcified tissues to remove calcium salts from the mineralized tissue, resulting in preservation of organic components. This is a cryostat, which is an instrument that is used to freeze the tissue and also to cut the frozen tissue for microscopic section. The rapid freezing of the tissue sample converts the water into ice. The firm ice within the tissue acts as an embedding medium to cut the tissue. The temperature needs to be maintained between -15 to 30. This is a freezing microtome which is equipped with a stage upon which tissues can be quickly fixed. Once the tissue is fixed, it is frozen using either liquid carbon dioxide or liquid nitrogen. The frozen tissue is then cut into sections using this microtome. The prepared slides are then collected and taken for examination. A special thanks to our guide, Dr. Abhirami, for helping us out with the procedure and taping. Thank you to Dr. Meera for providing the necessary content to make this possible. Thanks to the pathology department for providing us with this opportunity to witness the procedure and being able to showcase it to our fellow students. A final thank you to all the lab technicians for accommodating and assisting us.